We are live at 8:30 prep. It's Easter Monday. I know a lot of you had off school today, so I appreciate you tuning in because you are so bored. My eyes kind of bugging me today, so the bright light. So don't bother me if I wipe away the wetness. Weirdly enough, I have to wear a contact and glasses in my eyes. So today is systems of equations, and we're going to go through this all week. It's a question that comes up quite often on the SAT and the ACT, and that is how systems of equations work together. So let's teach a quick lesson. This week is going to be a fast week. They won't be very long videos, and then I'll put together a worksheet at the end of the week and post it. So if we did a system of equations by graphing, and we did something like this where we had two lines, we would say that the system had a solution because they crossed. So the first thing we have to say is there's a solution. So let's call this line 1 and this line 2. And we know that there's a solution to the equations from their equation. So this is the graph of the equations, and we know it because the slope of line 1 does not equal the slope of line 2. When the slopes are not equal, there is a solution to the systems of equations. All right, that's number 1. Number 2 is if they're perpendicular, or that is they come together at a right angle. We know that's the case because the slope of line 1 is equal to the opposite reciprocal of the slope of line 2. They'll never put it graphically on here. Well, I shouldn't say never. More than likely won't put it on here graphically that it is a right angle with a right angle measurement like this. They will do it with the equations, as we'll see here shortly. And then if I drew another line and called it line 3 is parallel to line 1. And that means no solutions. This is a very big thing for both the SAT and the ACT, that there are no solutions. And that is because the slope of line 1 and the slope of line 3 are the same, but their y-intercepts are different. So if you notice, here's the y-intercept of line 3, and here's the y-intercept of line 1. They don't ever touch in the xy plane. And lastly, we have infinite solutions. And infinite solutions are the same line. They have the same slope and the same y-intercept, and that is just one line right on top of another. So line 4 and line 1 have the same slope and the same y-intercept. What do the questions look like? Here's a nice one off of the SAT. Today is SAT and ACT together. And it shows a system of equations, and they want to know something very simple. Notice it's in number 2, so it's really, really easy on the multiple choice. And it says the graph above shows Paul and Mark during a race. Paul and Mark each ran at a constant rate. Constant rate, underline, that always means a linear function. Mark was given a head start to shorten the distance. Paul finished the race in 6 seconds. Mark finished in 10 seconds. Mark was given a head start by how far? Now, this really isn't too big of a system of equations. The head start is right here, which is between 12 and 24, which is 18. So each one of these marks is 6, 12, 18, 24 on the y-axis. So it shows the graphical representation of a system of equations. I thought that one was kind of fun. It's super easy. It's longer to read than to solve. Here's another SAT question, and that is given two systems of equations, and they flat out tell you it's a system of equations. What's the value of x? So they give you y is equal to 2x, and then they give you 2x plus y, 1/2, blah, blah, blah. So we're going to substitute this up here. So we're going to use substitution of y for the other y, and I'm going to get 1/2 of 2x plus y, which is 2x, is equal to 21 over 2. I can multiply this whole thing by 21, or excuse me, multiply this whole thing by 2. That cancels the fractions. Because they're multiplied on both sides, I can just get rid of the denominator, and I get 4x equals 21, or x equals 21 over 4. You can grid that 21 over 4, or we can divide that out and tell what's 21 over 4. That's going to go in 5.25. That's the answer. So it fits as a decimal or a fraction. There's 4 places on the grid in, no multiple choice on this one, and that equals 21 over 4. Now here is another SAT, and it's a system of equations. They didn't ask us here, in this case, what's the value of x, that we could plug it back in. This is the SAT's primary objective, is to make sure you can't use any test prep tricks, that you have to solve this algebraically. But there is one really nice thing they do. When they show a system of equations in standard form like this, they almost always make it easy to do elimination. Notice it's plus 3y minus 3y. So if we add the two equations together, we get 7 plus 6, which is 13x, equals 8 plus 5, which is 13. So x is equal to 1. I then have to plug that back in and solve for y. So I'm going to say 6x minus 6 times 1x minus 3y is equal to 5. Man, I can't write to save my life today. It must be a Monday.
But 6-1 equals as well.
6-1 is equal as well.
Yeah.
Why don't we just do that one all over again?
There you go.
We'll just change the color. We're going to say 6 times 1 minus 3y is equal to 5. I'm going to move the 6 to the other side, and I'm going to get negative 3y equals negative 1. Y equals 1/3. So x equals 1, y equals 1/3. You have to be able to do fractions. This is the non-calculator version, and you have to know that 1 is 3 over 3 minus 1/3 is 2/3. So that took a whole lot longer than it should have. All right, here's a classic kind of word problem, kind of systems of equations, but they give us the equations and they describe it, and they say in the equations above, B and C represent the price per pound in dollars of beef and chicken, respectively X weeks after July 1st during the summer. So the price fluctuates on a linear equation. Notice it's the typical SAT, which is B plus MX. We've gone over that in equations several times. What's the price per pound of beef when it is equal to the price per pound of chicken? So we have to solve for X and then plug it back in to get the price per pound. Notice how much underlining I do. I like to touch the test. Those of you who are taking the test coming up will more than likely have to take it on a computer online somehow. So there's going to be an announcement, I believe, by the end of the month where the SAT and the ACT come out and say there's going to be a test online by, let's call it the end of July, probably the beginning of August, somewhere in mid-August to September, if they ever let us back in again. All right, what do we have to do? We have to set them equal to each other. That is, they represent the price, respectively. What was the price when it was equal to the price of it? So I says 2.35 plus 0.25x equals 1.75 plus 0.4x. One of my favorite things to do is when there's decimals like this, notice that the decimals are all prices. I can just use whole numbers, and I could say 235 minus 175, which is 60. And then 0.440 minus 25, which equals 15x. I can just multiply everything by $1, 100%, and get rid of the decimals. 60 over 15, put a star next to this bad boy. This is one of the favorite math questions on the SAT, and that is 4 times 15 equals 60. So x equals 4. I'm really surprised it's not one of the answer choices over here, but it's only a number 11, but I would have put that in there if I was evil. So now I have to take 4 and plug it back in. Looking at the equations, I see 0.25x. 2.35 plus 0.25, which is 1/4 times 4 substituted for x. This equals 1. 2.35 plus 1 is 3.35. Sorry my eye is watering so badly. I should have been careful with my contact. I've got an astigmatism, so I have to wear a hard contact. All right, we've got 2 final questions coming in here. This is only going to be a short lesson, and this is a classic. The equation below are linear equations of a system where a, b, and c are positive integers. Which of the following describes the graph of such a system of equations? Parallel lines, intersecting lines, and a single line. A single line would be that the slopes are the same and the y-intercepts the same. Parallel lines are the slopes are the same and the y-intercepts are different. So what we have to do is put both of these into slope-intercept form, which is solve for y. So let's take the first one, and we get y equals negative b over ax plus c over a. And the second one, we get y is equal to positive b over ax plus c over a. That's solving for them. Notice that their slopes are different. So they definitely intersect, but they're not opposite reciprocals, so they're not parallel, they're not perpendicular. They are not the same, so they cannot be parallel. They're not the same, so they can't be a single line. They are two only, or an intersecting line. Put a star next to this bad boy. The ACT has used this style of question with lines in standard forms to do a system of equations for many, many years. It's one of their favorite questions. Here we'll see it again. This is an ACT. It's a number 49, so it's in the hard. It's in standard form, and for what value of a would make the following system of equations have an infinite number of solutions? That means what makes them the same line. If we go back when I drew the red line over the black line, they are exactly the same. That is the infinite number of solutions. So I've got to turn the top line into the bottom line. So if I take and multiply the top by 3, 2 times 3 is 6, negative 1 times 3 is negative 3, so 8 times 3 equals 4a. Divide by 4, I get 2 times 3 equals a, or a equals 6. Answer choice B. And that's systems of linear equations, a little preview just because I made one board for the whole week. Tomorrow is going to be systems of inequalities and how they like to put the systems of inequalities back and forth. Tonight was 8:30 prep. Thanks for joining me. I hope you're all safe, washing your hands, and not too bored in quarantine. Send me a meme, send me a note. I'm Phil at 3R Prep. I'd be more than happy to answer any of your questions because I'm just as bored as you are. So we'll see you tomorrow night for 8:30 prep.